Right, so I'm just going to record this as well, so you can always look back at this. Right, so for this one, we've got this clear context. Okay, and there's lots of numbers. So approximate file size. So let's talk about this. We're not saying it exactly. We don't have to necessarily come up with a actual final number because we've got no calculators in the exam. So you can look at this and you can say, right, well, obviously the width and height are going to have a factor. So we've got, so I would say, when I was answering this, I would say, right, okay, so that's 96 times 96. So that gives me how many pixels. So I can calculate how many pixels in this image by multiplying the width and height, which is what a lot of you did. Okay, so let me flick to the whiteboard. If I try and be very clever here and put a whiteboard at the side, I might have to zoom out a little bit. Yeah, that's wide enough, I think. Put my whiteboard on the side. Right, let's create a blank whiteboard. So for that first question, right, so what I'm going to do is I'm going to say number of pixels. So use number dot. I could put hash, because that means number as well. So the number of pixels in image. So yeah, I am explaining is going to be 96 times 96. So approximately, that's going to be 100 by 100. So that's approximately 10,000 pixels. I don't know exactly. I haven't got a calculator. Okay, but that's an approximate. So we've got 10,000 pixels. Right. So each of those pixels is 8 bits because we're using 8-bit color. So the color depth. So for each pixel, it's going to take 8 bits. So the total number of bits, and I mean, they've given us quite an easy thing here. The total number of bits to store the image data is going to be 10,000. Remember, this is approximate times 8. So that's 80,000 bits. But we're clever. We know that a bit or 8 bits is actually what we call 1 byte. So actually, if we divide that by 8, so that gives us 10,000 bytes. Okay, approximately. Now, that's for one image. Now, it said that there's 20 icons in this set. All right, so with 20 icons, we've got 20 times that. So total for set is going to be 20 times 10,000. We could leave it in bits if we wanted. Okay, as long as we say bits at the end. But we're going to say that. So that's, what, 200 kilobytes? So 200 kilobytes. Because each image is 10 kilobytes. And we got 20 of them, so it's 200. So it's really important, gents, to explore the numbers that you're given if you're given numbers. Talk about the context. Remember the other thing that we can talk about. So we've got the width, the height, we've got the numbers of pixels. Now, if this was 16-bit color, then obviously when we do this calculation, we'd have got 160,000 bits, and then we'd have divided by 8 to get the number of bytes. So the pixel depth matters. Okay, so you can start from that and then say, all right, so divide by 8. So I might write here, divide by 8 to get number of bytes. Because you could have been given a 4-bit color, which meant you could actually pack 2 pixels into a byte. So it would use half the number of bytes. And remember, that's one of the ways that we can reduce the size of an image by reducing the size of the palette. So how many bits we use for every pixel. Okay, so it's really important that you talk on like that and use the context of the question. Okay, right, moving on. If you've got any questions, whack them in the chat, gents, and I'll respond to them. Okay, so question 2. You'll get questions like this in lots of different contexts. They're basically saying, you know, all that binary stuff, you know. Let's ask you a context question. We're talking about pictures, but let's talk a little bit about what you know about binary. So if I'm using 8 bits, and the answers to this were really good, and I was quite pleased with this one. Most people got this. So if we're using 8-bit color, so 8 bits for every pixel, remember all this represents is a color number. So we have a color number from 0, and they're saying, so hang on, what do we get up to? So if you've got no calculator, so you can't use the clever formula of 2 to the power 8 if you can't then calculate it. So remember, there's another way. So if we want to do this in the dumb way, we go, right, okay, let's just write down the column headings for 8 bits. So that's 1, 2, 4, 8, 16, 24. No, it's not 24, you idiot. It's 32, 64. So that's 7 bits. 8 bits is 128. And remember, what we can then do is if we just go one more. So let me put a fatter pen on there. Do one more column. That is what 2 to the power 8 is. So you do not need to try and multiply 2 to the power 8 or do 2 times 2 times 2 times 2. All you've got to do is write down the number of bits. So if they'd have asked us for so the answer was 256, but if they'd have asked us for a 4-bit per pixel, how many colors, then we'd have said 16. Oh, let me make the pen fatter again. We'd have said 16 because that's the next column. So that would have been, for this question, it was the values 0 to 255. So 255 being all the ones. Because you could have added it up. You could have just gone, right, add all the column headings up. But you would always then forget about the 0, which is why this is the better method. So if I'm doing a 4-bit number, write down the 4 columns and then write down the next column. That is your answer. If I'm doing an 8-bit number, same thing. You might get asked the same question in the context of character sets. So they may say to you, if I've got 6 bits to store some characters, how many different characters can I represent? So again, I go, right, 6 bits. So that's 1, 2, 4, 8, 16, 32. That's 6. So you've got 1, 2, 3. So I've got 6 columns. And then I go, right, well, what's the next column? 64. So actually, with 6 bits, I can represent 64 different characters. Remember, it's all about numbers. Everything is a number to that computer. We're just, in this part of the course, we're talking about how we use those numbers to represent data. And in this context, we're talking about a color number. That's all it is. Remember that color number is then looked up in a palette. So I'd have a palette of colors and it would say, oh, color 63 is lime green or whatever. Okay. Right, moving on. So question 3 says, James has created a video clip to promote something. Oh, his streaming service. I'm just trying to scroll the map out. All right. And he's going to use MP4 compression, which is like video compression, to store the video clip on his hard disk. State what is meant by the term compression. Now, what I noticed on a lot of people's answers was that obviously it was written on their OneNote or something, and they copied and pasted it to it because you could tell because the font changed. All right. So whenever you're doing this, the exercise isn't have I got the answer and let's copy it in. It's write the answer. I want you to get used to writing, from your brain, putting down in your own words an answer that fits with the context of this question. So obviously, I think most people got this correct. Yeah, compression is reducing the size of a file. There are loads of methods, and it didn't ask us about how can we do that. but we did. We reduced the file size of a file. Okay, didn't ask us what the consequences were, because that's the next question. So one real big takeout from this is always read, especially if, and generally this would be a multi-part question, it'd be like an A, B, C. Always read an entire question just to make sure that you're not answering the next bit. Because what I find students do is, if they put an answer in part A and then they get to part B and they've already written the answer in part A, they'll get confused and think they've got to write something different. So you've got to be careful that what you don't do is like sort of whammy yourself. So always give it a bit of a read, just flick down to the next one. So for this one, you can see it says, right, okay, advantages. Now the key for this is a describe question. So some people did put the advantages down, but they didn't explain it. And they didn't explain the context. Some people did this really well. Okay, so when I'm answering this one, I'm gonna state something. So I'm gonna say my first one, reduce file size. I'm in red, but it doesn't matter. Reduces file size. That is an advantage, but I've not described why it's an advantage in this case. So what does that mean? So that means they can store more films or more clips. Did it say movies? It didn't really actually say what it was. So it can store more clips, which can lead to more variety. So I'm really going to town on this. So if I've got more storage space, then obviously I can store more stuff. You haven't got unlimited space. Okay, so you have to make some decisions. And the better I compress things, the more things that I can offer. More variety for my subscribers. I don't have to rotate my clips as much as maybe I would need to if I wasn't compressing them as well. Okay, so other advantages of that file size would be things like, okay, so that's less storage needed, would be another one. Which means I could maybe reduce the amount of server space. So I could reduce the amount of server space I need. And I'm probably renting that as well. So reduce my rent. Now, obviously, we're talking about scales here, but you know, we haven't really got much more context than that. So there are lots of reasons why that file size. Obviously, one of the mega benefits for a streaming service is reducing the file size would reduce the bandwidth requirements for transmission. And some of you did say this, and this was good, and then you did explain that. So that would allow people with not very good or lesser connections, so it would increase the usership. And in fact, allow it to be delivered over mobile devices as well. And the devices that can be supported. So like mobile devices, ideally, because people pay per gigabyte for their data, unless they've got unlimited, and that's not the majority. As some of you know, you have got a limit on your data. So if we can compress that video better, so we can like access mobile devices, and obviously if you can access mobile devices, which is what a lot of people use to access content these days, then you're going to increase your throw, who you can attract to your site. So you don't need as good an internet connection. If you look at streaming 8K video, I think it needs 48 megabit connection as a minimum, which would be rubbish probably at that. And they're constantly coming up with, I think they've just developed a new one. Well, I say just, it's been about 2 years in the making, but AV1 is the new format, which can halve the size of 4K video for transmission, because they started looking at that for 8K video. Not that anyone's got 8K screens unless they're a lunatic. But yeah, but it is about the context, chaps. If you've got an explain and describe, it's no good just stating things. Potentially, you're going to get half the marks, potentially, if you stated 2 right things. But you've got to be careful. It is about that context. It's what we've been talking about since September. Context is king. So it's all about the context. Okay? At the end of the day, even if you get a simple question, I'd like to see you tackle it with context. All right? That's what I'm pushing for. Right, okay. And then a disadvantage. It did actually just say state, but this is the sort of question where I'm thinking to myself, if at this stage, when you're answering these sorts of questions, you can say, here's a little bit of explanation, here's a little bit of description of why that statement is true. If you can get yourself into that mindset of that's how we tackle questions, what you will find is when you're tackling the bigger questions, hang on, someone said something, I'm sure. I'm going to put my glasses on, bro. Yeah, I mean, that's it. That is, in essence, your question is exactly what I'm saying. It's all right, Mark. I understand. Mine, because I'm recording OBS and I'm streaming at the same time. My laptop fan's going like the clappers. So yeah, I understand about the overeating. So I'm recording this, so I will upload this afterwards anyway. So you've got it. So yeah, don't worry about that. Yeah, it is all about that. So I want you to state something. Always start with a statement, but then you need to say, why is that statement answering the question? What is that statement in relation to the question's context? Okay, that's the real killer for me. It's where we throw lots of marks away. And like I say, some people are really getting that now and nailing it. Other people, we still need to work on that. And that's we need to keep pushing at that. I'll say, so for question 5, we say a disadvantage. So what I could do for disadvantage, I could say lower quality video and audio. And a lot of people did say that, because obviously that if we compress too much, we get, so low quality video and audio for the viewer. Depending on how heavily compressed we'd make it, depending on the level of compression. If you've ever watched Freeview channels, you'll notice that, like channels like the BBC, ITV, they've got compression that really doesn't impact on the image that much. But if you go to the lower end channels, so I don't know, like Horror Channel, they might use higher compression, so you get chunkier compression, and you notice this pretty badly on scrolling text. You'll see that the images get all like little pixelated blocks, and the bigger those blocks, the heavier the compression is. And you notice the difference when you're watching HD channels and SD channels. So like standard definition channels and your full-on HD channels. And you do notice it. You can see that the compression methods are lighter. Okay. Just because something's 4K streaming though, doesn't mean you're getting 4K images arriving at your machines. you've still got compression. It all really depends on the compression. I mean, you can see what Amazon do. Things like Instagram and Facebook, they have some pretty brutal compression algorithms because obviously they don't want to have tons and tons and tons of data on their servers that they're paying for. So if they can reduce that space, they will do. So like Facebook and Instagram can really butcher pictures and video because they heavily compress it. So it all depends on the compression method used. But sometimes what you find on streaming services is they are getting metrics about what your bandwidth or how good the connection is or how stable the connection is. And they will offer you a different feed. So you'll notice this on YouTube, the quality setting on YouTube. If you leave it on auto, what YouTube do is they look at the response times they're getting from the handshake signals that they're getting on the network to your computer. And if they find that there's a bit of lag, they'll reduce the quality. I mean, I think the lowest that YouTube goes these days is 360p, so that's 360 vertical lines. Even if you had the video in 4K, which is 2160 lines, you might only be getting 360. So that's heavily junked, and it can be really blocky and horrible. All my video, I don't know what you're receiving at your end on Teams, but I record my video at 1080p. So this, so that's why my fans on my computers are going ballistic, because there's a lot of work going on to stream that onto the hard drive. Well, luckily I've got SSD, so it's not too bad. But yeah, so the compression methods we use, that matters. Okay. Right, number 6. There's quite a few people were right on this and give me some really good explanations, and then a few people sort of went around the houses a little bit and never really got to the meat of the question. Right, so we've been talking about streaming. So streaming is all about quality. About the quality settings. Streaming is about achieving compression by removing data. So as some of you have said, is like you know, you can remove data by reducing the resolution, reducing the number of colors. These are all standard ways of reducing for image data. You can, if it was sound, you can reduce the number of bits per sample, but there is an effect on that. So we're throwing data away, which allows us to get compression, good compression, and we call that lossy. So it's about removing data, not because we can't perceive it. You must never say that about lossy compression. So it's removing data, and we call that lossy. So some of you really hit the nail on the head with this and said, oh, because they're using lossy compression, which is exactly what we wanted. So this is what we call lossy compression. So it achieves really good compression ratios. Because we extract information, we throw that data out. We can never get that data back. So can't get the data back. And that is in essence the whole point of this question. So you can't ever get that data back because you've taken it away. If you've reduced the number of colors, you can't make that up at the other end. So you can't get that data back. Okay, so you're accepting a level of quality. So for instance, if you were compressing a picture for a website, for a thumbnail, we're not bothered about a massive picture. We want a small picture so we can reduce the resolution. We can probably get rid of a load of colors. As long as it has a vague representation of something, that's acceptable. So it's all about acceptable levels for what we're using the data for. But with software, you can't afford to lose anything. So we can't remove anything from software. What bit of the software are you going to throw away? if we've got data files, so like a Word document, you can't like say, oh, I'll throw half of it away, because obviously that's gone. You never get it back. Can't remove any code or data. We have to use what we call, oops, that's not very good. We have to use, I got on to the next word, that was the problem there. We have to use what we call lossless. So when you're using 7-zip or WinZip or LZW, they are lossless. So lossless compression methods. And these make sure that we can fully reconstruct. So we can always fully reconstruct. Now I know I'm going on and on, but I'm trying to like make sure that you're getting a really good wide view of what these questions are talking about and how they're drawing in your knowledge. So we can fully reconstruct the original file before compression. So we can always get back. Because it's important. So we cannot use the same methods that we use on a streaming service, or that we'd use for compressing audio, because we're throwing data away. So the upshot of that is that these lossless, so you never get as good a compression. So lossless compression is never going to be able to squash files down as well as lossy. So you can't compress as well. So again, that's another, if you was to like compare and contrast lossless and lossy compression, one of the things you would say that they both do is they make files smaller. Okay. But one thing you would say where they differ, you would say that lossless compression has lower compression ratios than lossy. So it can't compress as well as lossy. So without getting into like mega detail of the types, that's about all you can really say. There are certain lossy compressions where you can really go to town. If you really don't care about the quality, you can get like 1,000-to-1 ratio. So 1,000 times smaller than the original file. But, you know, it depends what you're using it for. Lossless, I don't know. You're lucky if you can get 70% compression. Often it depends on the type of data. Okay, how well it compresses. Programs don't tend to compress very heavily. This is a thing from we've always tried to compress data and we've always tried to compact data. Back in the day when the pirates were copying games on floppy disks, some of the pirates had really good custom compression routines that they used, and they could get games that were on 2 floppy disks onto 1, or they could get several games on 1 floppy disk. They had really good compression systems. But yeah, there are standard ones, but there are custom ones for certain situations. Okay, so again, it's all about that interrelationship between your knowledge and context. Okay, and I am going to keep pushing and pushing at you to always focus on the context. Okay, so that was question 6. Right, question 7. The term sound sampling. Right, it's really important when we're talking about the audio that we use the technical terms that we've got at our disposal. All right, so sound sampling is a process, and so it's a process that takes analog sound level. So it's, oh dear, analog sound, that's not very good, sound waves, and it converts them to digital samples. Now what we mean by that, and there's nothing to stop you doing a little diagram. This is the classic diagram. So we've got volume or amplitude going up. Here's our sound wave. And we've got time. This is what we call the time domain of audio. This is our analog wave. You can see it varies. Analog means infinite variance. Okay, so there is, from that volume to this volume, there is an infinite number of amplitude levels. So this is our analog. But computers can't deal with analog information. So what we need to do is we need to convert it into a digital. We use something called an analog to digital converter. So that's analog to digital converter. And what this does the sampling. So it takes a look at this level of the wave. Okay. Just put converter there. So we look at it and we say, right, what is it? What level is it? So at a certain interval, which is the sampling rate, so this is when we take our samples. I haven't put a scale on here on purpose. So what we do is we sample the sound. So we go, right, there it was at that level. There it was there. There it was there. At this point, that's what the amplitude was. So we're sampling the amplitude of the wave form. That's sound wave. So we just do this. Now, I'm not suggesting you did this in the test. You have to do this in the test. But I'm just saying you can use an illustration to help you if you find it difficult to explain it. Okay? So when and let's say we did a sample there as well, obviously at the start. So when we look at this in its digital format, it ends up looking like this. The graph, it ends up being like a graph of connected points. So the red line shows what the computer records the sound as. And you can see that we're missing details. We've missed this little bump here. We've missed this dip because that was in between the sampling intervals. And we've missed this little peak. And that is what the sampling rate, and this is what it controls. And a lot of you did say, for sort of question 8, how many times we examine the sound wave per second. That's what the sampling rate is. We often describe that in hertz. So cycles per second. So how many samples per second? So if I do 10,000 samples per second, I will be sampling at 10,000 hertz. Okay. So the sampling rate is how often we do this sampling process. Now, question 9 said describe the effect of increasing the sampling rate. So what was really good is that quite a lot of people did get the 2 points and explained it. So every time we take a sample, okay, we're recording a piece of information. The more samples we take, the more information that we're going to record about this sound. So an obvious consequence is greater the samples. So if we increase the samples, we increase the file size. In a raw audio file, in stereo, so 2 channels, so that's 2 separate sound waves, we would probably use a decent quality approximately 172 kilobytes per second. All right, so for every second of audio, we store 172 kilobytes of data. That's how fast we sample. We sample at 44 kilohertz, roughly. Okay, double the human hearing. All right, so there is a consequence, but the benefit we get if we sample more, so if I was to do some extra sampling points, so I double the sampling rate, I'm going to get that peak. I'm going to get that dip. I'm going to get that dip. I'm going to get this bit. All right, so I get a more accurate representation of the analog signal. We can't represent analog things exactly, but by manipulating the amount of samples we take, we can get closer. Of course, this also ties in with the last question. Now, this was a stupidly worded question, to be fair, because they said bit depth. Now, we know bit depth in terms of pictures, so how many colors, but it's also, I think they were asking you to carry on about sound. All right, but bit depth is a generic term for the number of bits we use to represent things. So in pictures, it's how many bits do we use to represent the number of colors. In audio, it's how do we represent the amplitude. So the bit depth in audio, oops, I moved on to depth. So the bit depth in audio refers to the number of bits, so it's the number of bits to represent the amplitude. So when we take a sample, we're actually saying, right, okay, record the number, but we're going to be limited to a certain number of bits. So if we was to do 8 bits, that means we could represent 256 values or levels of volume. If we was to use 1 bit, we could represent 1 level of amplitude, either no sound or there is a sound. If we used 4 bits, we could represent 16 levels. Okay, so it does matter in how accurate we record the height of the wave. So the bit depth in audio is the number of bits to represent each sample. So the height of the wave. So again, it becomes the more bits, the more accurate we can represent the volume. Now they said state, but I'm just going that little bit further. I'm going a lot further, okay, because I'm using this as a recap as well. The amplitude or volume of the wave at that particular moment in time when we did that sample. So if I don't use enough bits, then I'm not going to very accurately record that. So let's just have a look at what that might look like on our graph. Let's say I just used 4 bits. So I could represent, so I'll do this in green. So I could represent, oh, let's make a fatter pen. Hang on. So I could represent 0. I could represent full volume. So that would be 1. Then I could represent maybe 2/3 volume and represent 1/3 volume. So that's 4 values: full, 2/3, 1/3, and 0. So each time I make these samples, I've actually only got these 4 markers. So this is just using 2 bits. So when I take this sample, I go, right, well, which one actually is it? So actually, I'd be saying it was there. Then the next sample, I'd say, well, it's closest to that, so that's how I'll represent it. This one's close to there. This one's close to there. So you can see how the number of bits affects this as well. So it doesn't matter how accurate, how many samples I'm taking. If the number of bits for each sample is so low, then I lose the accuracy again. So again, all of these actually look like this. That one's down here, so that's going to be a third. And so on. So my actual representation of the waveform, if my bits per sample is too low, looks like this. So just to draw that out, so I ended up with something that looked like that. Well, that's nothing like the original wave. The original wave was like this. So we've lost all that detail. Okay, so the sampling rate allows us to record higher frequencies, which gives us better quality audio. The bits per sample allows us to represent the volume, the fluctuation in the waveform. So we need to make sure that they're both high enough to pick up the noises and the sounds that we want to pick up. But I was fair if people started talking about colours, then because it just said bit depth, I gave you the mark for that. Right, okay, so I'm going to stop that recording. Well, I'll stop the recording in a minute. I want to say what you've got to do off the back of this. So, what I would like you lot to do, gents, is I want you to look back at your questions where you threw marks away and lost marks or dropped marks. I want you to write a little bit, and I'm going to create an assignment for you to put this in. I want you to do a little bit of a review, and I want you to identify the following. So, what questions did you succeed at? But the key question for me is, and why? Was it because it was just a factual question and you've got your facts nailed down? And that's good. That's a positive. Okay. So I don't want this to be a negative experience. Whatever score you got, I want it to be a positive experience. So that's the first thing. Then we're like, right, the questions you lost marks on. So the questions I lost marks on, why did I drop marks? So if that is to do with the fact that you got the right stuff, but you didn't explain it, or you didn't tie it to the context of the question, or you didn't use the data that was in the question, so you didn't work off the examples that was there. Often what you get on some questions are they'll say using this, give examples from. So if they present you with a program and they say tell me what variables are in the program, which is what I'm going to have a go at doing with you next week. We're going to start trying to do, I can't do some physical programming, but we can do some paper-based stuff. So I'm going to start with identification with you. Yeah, so what was it that made you lose the marks? Was it you didn't relate it to something else? Was it you didn't tie up? Was it you didn't use technical words? These things are important. Okay. And then what I want you to do off the back of all of this is I want you to try and write a summary of perfect answers. To these 10 questions. Okay. So that you've got it. If you got 20 on this test, then you've got your perfect ones and you haven't got really much to do. But I still want you to think about that. Okay, that first question. So off the back of this, moving forward. Oh, my writing's really bad today. Moving forward, what do I need to improve? And this is the final question. So what do I need to do to improve my knowledge and whoops, and my ability to access the marks. Because at the end of the day, you might be able to have a really good verbal conversation with me, and I know some of you can do this, but when it comes to writing it down, that's when it sort of we hit a little hiccup. So that's what we've got to try and work on to access marks. So what I'm going to do is I'm obviously going to upload this video, but I'm going to screenshot this this bit of the whiteboard. Hang on, if I zoom out on the whiteboard, I can get it all on. Right. So I'm just going to grab a screen grab of that using Windows S, which is really cool. Right, so I'm now going to paint that. So I will post a link to the video. I'll upload it in a minute. That's the end of the lesson. I want you to go away and do this and think about it. Don't sign out of the meeting yet because I haven't done the register, so I need to do that. Right, so theoretically, let me just double check. Right, I've just posted that into the chat. Okay, so that is our what you need to do on next steps. Okay, next week, I think it's Monday, isn't it? We have our next lesson. Yeah, on Monday, what I want to do is do the first bit of I'm going to stop the video there now anyway. So stop recording.